Theory of plate tectonics. The importance of understanding the theory of plate tectonics can't be understated, as it is the basis which all of our geological understanding is underpinned. With our deepest drill holes not exceeding the extents of the crust, most of our evidence supporting plate tectonics is indirect at this point. While indirect evidence may be all we have, the theory works well to explain the geological occurrences that we see today, just as the theory of quantum mechanics is a great guideline for explaining the quantum world, a realm that we can't readily observe with our eyes. The Earth's heat engine. Earth's geological structures are the result of two heat engines. Firstly, there is the sun, which controls the weather on the Earth's surface, and therefore plays an integral role in the rock cycle, which we'll get to very soon. The other heat engine is the Earth's core, which is hot and sits roughly 6,370 kilometers from its comparatively cool surface. The differential in temperature between the core and the crust causes heat to flow away from the core and out to the mantle. These convection currents flow in a cyclical manner, releasing heat upwards as they rise up through the cooler mantle. The then cooled convection currents are drawn back to the hot core, where they are once again heated and the cycle continues. You may be wondering, how does the flow of heat within the Earth fit into the theory of plate tectonics? Great question. Let's start by looking at the various zones within the Earth's interior. Earth's interior. The interior of the Earth is broken down into three main zones: core, mantle, and crust. To begin, we start at the Earth's core, which is made up of two parts, the inner and outer core. The inner core is solid and primarily made up of iron, while the outer core is liquid and is primarily made up of iron and nickel. Next is the mantle, the largest of the Earth's main zones. Although it is solid rock, the mantle can behave much like putty as it is heated. This putty-like quality allows the upper lying crust to sink down into areas of high density and thickness, and vice versa, moving upwards in areas of less density and thickness. Plate tectonics breaks the mantle up into two portions, one which is grouped with the crust and is more rigid, forming what is called as the lithosphere. Second, and laying underneath the lithosphere, is called the anisonosphere. The anisonosphere is a plastic zone of the mantle, which is thought to act like putty, allowing the lithosphere to move, albeit very slowly, on top of it. The lithosphere is made up of 7 main and a few smaller plates, each of which is shown here. The 7 main plates are Pacific, North American, Nazca, South American, African, Eurasian, and Indian Australian. Quickly recapping, it is the convective heat waves from the Earth's core which is the essential driver of the plates' movement. The plates' movement and their interaction with one another is key to understanding the geological structures which we see today. Just to note, it shouldn't come as any surprise that many of the world's top mining jurisdictions lay in close proximity to the plate boundary areas.